Hello everyone, welcome back. So today what we'll be trying to do, because I haven't done this before, on the right is these, I'm not sure how to pronounce this, but Koch Snowflake maybe, um, which is basically given a segment between 2 points, recursive, well, just generate a new two new segments, well, in total, four new segments, which will be, let's say, a third of the way true and two-thirds of the way true, and then a equilateral from those 2 points, but you remove the base of the equilateral triangle, basically. As you can see on the right over here, let's say this segment gets split into four segments, which gets split into four again segments, so on and so forth, right? So what I've tried to do just so far is just to create an equilateral triangle from 2 points. That's just it. So create a triangle from 2 points. So just wanted to get the concept there. So I'll be explaining on the whiteboard. So let me go right on there. So I'm sorry again. I personally don't like the red marker, but that's all I have. So let's get started. So like I said, the goal is, let's say, given this point A and this point B, we need to, so this is a segment, right? So we have concept of segments, which has to start with 2 points. And this construct the segment, right? When you draw it, you draw a line between those two. The goal is to split the segment at, let's say, a third of it and two-thirds of it. This is not to scale, but anyway. So create those new 2 points. We'll call it maybe C and D. And from those two segments, what you'll want to do is create an equilateral triangle, right? Meaning same length on each side of the triangle, and also same angle, which is 60 degree within each triangle corner. So in this case, it would create a triangle like this, right? Let's say, and you remove the base, so you don't keep track of this segment over here, right? So you create this segment, and those two segments over here per every segment. So this segment will get the same treatment eventually, right? The big thing here is to getting the points. These points should not be too hard, right? But getting this point here is the challenge, I believe. At least for me, it is. So let me erase this. Oh, sorry. Let me erase this. I really don't love the red marker. It just stays on the whiteboard. I don't know what it is with it, but hopefully I just buy a blue marker sometime soon. All right. So the goal is, at least to me, right, the challenging part to me, right? So given these two segments, how can we find this point over here, which creates the equilateral triangle? So let's say the 0, 0 point of our canvas is over here, right? This is 0, 0. Okay, this is A and this is B, right? This will eventually be C, right? So A, let's say right now A is like, I don't know, this could be, let's say 5, and this could be, let's say 4, right? So A is 4x and 5y. And B is, so 5, same. And let's say this gap is, I don't know, let's say this gap is 6, right? So it's 6 plus 4, right? So we just have 10 here, 10, 5. So that's our B point, and this is our A point. So the goal here, we know that this I'm just thinking right now. Okay, we could just get this vector, right? The B vector, remove A from B, and then rotate it 60-degree, right? Because this angle should be 60-degree, because all of the angles should be 60-degree regardless, right? This angle over here, this one over there, and this one should be all 60-degree. So we could just rotate it minus 60-degree, and then we have that point. But to rotate it, we first need to translate it back to 0, 0, and then rotate it, because we don't want to rotate 10, 5. We want to rotate B minus A and then rotate, right? So what we'll need to do is do something like vector dot sub for subtract, and we need to subtract A from B, right? So subtract B minus A, let's say, right? So B comma A in this case, in code, right? And this, let's say it's C, right? So right now we've moved B over here, right? So right now B is here, B. So B is here. Now we need to use, I'm just using P5 functions, right? So we can do C dot rotate, and normally whenever you have an angle, right? Let's say you have this circle. This is 0, 0 of the circle. Normally this angle over here is 0, and this is 90-degree. This is 180. This is 270, right? I believe. And if we were to do 30-degree, right, rotate 30 here, it wouldn't work because we would rotate it in this, not 30, sorry, 60. We would rotate it over here somewhere, right? But we want to actually move it up. So in our case, we need to rotate it minus 60. So this is, I'll just write minus 60 because it is minus 60, right? So sorry, not 30, but 60. But anyway, it's minus 60-degree, which is 90-degree divided by 3 times 2, right? 90-degree divided by 3 gives us 30, and 30 times 2 gives us 60. So, and I'll be using that instead of just 60, just because we're not going to use degrees, we're going to use radians amount for the angles, right? So it's going to be, in this case, 90-degree is half pi. Divided by 3 times 2, right? Minus all of that. That should give us this vector. So, and this is C, sorry, this is C. And then it should give us something like this. So this is C now. And then what we need to do is move it back to A, right? So that it goes over here, right? C. So to do that, we just need to add 5 plus 4, right? So we need to add A, basically. So we can do C dot add A, basically. And that will give us this point that we need for the triangle. And it shouldn't matter where. Right now I just did it on a straight line, just a horizontal line, just so that it's easier. But technically your A and B could be over here, right? B and A, it should still give us this point, regardless of the angle of A and B. Give me just a second, I'll be right back. All right, sorry, I'm back. Okay, great. So now we know how to get this point. That was my challenging part of this. But in the end, it's not that big, right? It's not really a complicated thing. It's, well, I mean, 3 lines of code. Technically, we could just put it in 1 line, just do dot rotate here and then dot add afterwards, right? It's not a complicated thing. I just needed to put it on the whiteboard and explain it to myself, right? So, and I'm sure you can do it too, right? It's definitely not too hard. So I'm just going to remove a little bit of it now that we know how to get it. Again, I'm really sorry for the red marker. I'll try to get the blue one back. At least that's my personal favorite, or the black one. It's just red. I don't like it that much. It's just the blue right now is a bit dry. I mean, it's dry markers, but hopefully you get what I mean. Okay, so segment has, let's say A and B. These will be X, Y. And these will be the original ones, right? So it'll be, if we were to draw it again, this will be A, this will be B, A. And now we need to split it at a third of it and get the last third of it. And then from here, create a new A and B for getting our C point. And then, so this A to B to C to B. Well, let me do it. So A to B is here, right? Okay, that's good. We've got it. Now, whenever we call, we'll have some, this we can call C, and this we can call D. All right, so C is also going to be equal to a vector eventually, but for the beginning, it'll be null. And D is going to be the same thing, null. Okay, great. And now as well, we'll have this third one, which will be over here somewhere, which will be also null to begin with. And we'll call this one A, B, C, D, E, I guess. So this will be E. So E will also be null by default. Now we'll have a generate function. So generate. And let me see at which point don't you see. Okay, so over here is my mark. Sorry, I just put a line there just to make sure I'm not writing over there. So generate, and we can have some generated over here, generated equals true or false, it doesn't matter. Okay, so if it is not generated yet, we will need to get C and D to start with. Okay, so C, let's start with this one. It's going to be 0, 1, right? So it's a third of the way through. So what we can do is just lerp between A and B, a third 1 divided by 3 of the way, right? So we can do, let's say, a new vector. I'll just do V, capital V, just to simplify the pseudocode. So V, and then lerp for X, so lerp A dot X and B dot X at 1/3 of the way. Great. And then do the same thing. Let me remove the D equals, see? And then this is the first argument, which is X. And then second argument will be lerp, same thing, of A dot Y this time, comma B dot Y, comma 1/3 again. So this will be our C point. And now our D point, sorry, not B, D, I also need to find some new towel, just because this one's getting a bit colored. Okay, so now D, okay, there we go. D equals the same thing as this one. The only parameter that changes is this times 2, right? That's the whole idea. I'm going to write it anyway. V equal lerp of A dot X, B dot X at 1/3 times 2, right? I believe this is right. Otherwise, you can just correct me, right? Because 1/3 of the way, 2/3 of the way, 3/3 of the way, right? Right. If I take one line segment, this is 1/1, 1/3 times 3. This is 1 over 3 times 1. And this is, let's say, 1 over 3. Yeah, I think that's right. I think. We'll see. Anyway, otherwise it's just the fraction that needs to change, but that's not a big issue. Okay, and then after this x, we'll just need the y, which is lerp of a dot y, b dot y, and 1 over 3 times 2 again. Okay, great. This is our parentheses and our second parentheses. Okay, there we go. Okay, so we've got C and D, and C and D will be our A and B from here, right? From this example that we did. So what we need now is the E. E point is the one we need. So E is going to be V vector dot sub. So create a new vector from the subtraction of B minus A, or in this case, it's going to be D minus C, right? So D comma C dot rotate. And we said minus half pi, I'll just write minus 60. It's minus half pi divided by 3 times 2. And then dot rotate dot add C. There we go. So that's pretty much the generate function. And then we recursively call this generate function for all of the following segments, basically. I think that's right. So let's try to implement this and see if we get it right. I'm sure we won't get it right the first time on, but it's fine. We're here to learn and make errors and then correct them, right? So that's totally fine. Okay, great. So let me remove this whole thing. Let me remove everything from here. Right, okay, there we go. So now if we take a look in here, this is just a blank page. That's great. That's what we want to start with. It's just an empty canvas. And let me make this just so that we can see everything. Okay, great. So now our segment class, what does it need? We said A, B, C, D, and E, right? Okay, so constructor will receive A and B. So this dot A equals A, this dot B equals B, and now this dot C equals null, this dot D equals also null, and this dot E equals also null. Okay, great. And we'll also keep track of if it was generated or not. So generated, right, equals false. Okay, great. Now we need to create the generate function. So generate is going to be creating this dot C, which is a new P5 vector. We can call create vector for that. And vector is no more complicated than just 2 points. And then there's methods to this class where you can add, subtract, rotate, for example. But it's just real simple math in the end. But anyway, we like to use the wrapper for right now. We want to make it simple as possible for everyone to be able to do it, right? So first value is the lerp between this dot A dot X, this dot B dot X at a third of the way there, right? A third. Okay, great. And then lerp again, and I'm just going to copy what we have in here and change X for Y, because that's the only change that is needed for here. There we go. Okay, great. So now we have C. Now let's do D. Great. So D, we'll do the same thing, but in here, we'll do times 2, right? And this is where I might be wrong, but it doesn't matter. We'll figure it out in the end. Okay, great. So now we have our 2 new segment, right? So I might just want to create an array of segments, right? So call this dot segments equals an empty array, right? Possibly, yeah, sure. Because we'll create a segment from both of those, with A and with B as well. So C will go with A and D will go with with B, sorry. And E will go with C and E will also go with D. Oof, okay, let's go with one thing at a time. So E equals p5 dot vector dot sub, and we need to sub B. But in this case, it's not B. We said it's D. And this dot C, right? Yeah, C. There we go. And now we need to rotate this. So rotate by minus half pi divided by 3, which is, this is 90 degree, minus 90 degree. And 90 divided by 3 gives us 30, times 2 gives us 60. Great, awesome. Dot add, and now we need to add, I believe, C. It is correct. This dot C, and we'll see. Maybe this is, all of this is wrong. I don't know. We'll figure it out. We're here to learn again, and we only make happy accidents. No mistakes here. Okay, great. I think we're good, and we can set this dot generated to true. And what we can say in here is if this dot generated do something and then return. And the do something will be basically calling generate on the other segments, right? On this array of segments. So this array of segments, we need to fill it in, right? So segments, after generating C, D, and E, we need to push into segments, push into segments, 4 new segments, right? So new segment, oh, and yeah, I mean, we'll push 4 times. So new segment, which receives, which will receive, for this case, this dot, for the first one, this dot A, and this dot C, right? Okay, now let's do it 4 times. Okay, great. Let me just format it. Okay, great. So the next one is C and E. And then the next one is E and D. And then the last one is D and B, right? I think that is correct. Okay, so now we've generated them. Now we need to show the segments. So we'll create a function called show. And what we'll do is if, oh, and also, forgot, but here, whenever it is generated, we just need to call it, call generate on all of the other segments, right? So for const s, just to be short, hopefully you are not, and hopefully name those like better variable names than these, right? This is real awful. I would not suggest it. Okay, so s.generate. Great. Okay, let me go down back to if. So if this dot generated, do something and then return. If it is not generated, it's simple. It's one single line between A and B. So line between this dot A dot X, this dot A dot Y, this dot B dot X, and this dot B dot Y. Great. Okay. Now I'll copy this, and if it is generated, then we'll need to draw 4 lines, or never mind. What we'll do, yes, correct, because I don't want. Sure, what I'll do instead is in here, I'll basically copy this loop that we have over here and just call it here. but instead of generate, we'll call it show. I think that is pretty much it. I think we're done. If it works, we'll see. So the first line segment, I'll just do it in the middle. So from here to over here, right? So middle height and start and end width, right? So we'll have const let segment equal to null, or just don't initialize it. Or you could technically just initialize it in here. Well, no. Okay. So here, new segment, which will get passed create vector and also create vector. First vector A should be width 0, height divided by 2, right? And the next one should be width and height divided by 2. Okay, great. Okay, now I believe, and let me first show it once. Let's see. Okay, so we have a line. That's good. That's good. That's exactly what we want to start with. And A is over here, and B is over here. Okay, let me remove the draw function. Eventually, we can use the draw function to animate this and whatnot. In the mouse press function, whenever I press the mouse, it should call generate, basically. So what we'll, and call show afterwards. So what we'll do is like this and call generate. Okay, great. Let's see. Moment of truth. Okay. I think we've got it. I think it's done. Awesome. I wasn't sure if that was going to work, but I think we've got it. The only thing here right now is that since we're not redrawing the canvas, it's still showing the previous lines that were drawn, and it's overdrawing on top of the actual lines. So what we'll do is just redraw the canvas, redraw the background, right? So we'll just create a background because right now we're not even drawing a background. So we'll just call background. We'll do the background white, sure, that's fine. And then do that every time we generate and show, right? So right before show, actually, but it doesn't matter. Okay, so let's see this now. Let me click once. Okay, good. That's actually what is expected. So let's take a look at this one, for example. Oh, it's really small. Okay, there we go. Technically here, and they're starting from the top, creating two, generating, and generating, right? So let me do it again. Okay, that seems right? We splitted all of the segments into 4 new. Again, and again, and again. It is great. It is working. So the actual, at least to me, the actual difficult part was to get the third point from the 2 vertices for the equilateral triangle. But we did do it on whiteboard. It is not that complicated, right? Once you get the basic principle of it, you just move back the vector to the origin, rotate it 60 degrees, and then move it back where it was. And then you got the point where you want. So really, you should try it on your own. I know this is the end of the video, but hopefully it took us 28 minutes, right? And I didn't do much before this, right? I just figured out the concept in my head. So maybe 5 minutes before the video, I tried something. So let's say 35 minutes in total. I think that is great time to be able to do this. So hopefully you had fun. Hopefully you can add colors to this pretty easily. I would say, oh God, I should not have clicked that much. Let me remove it. Let me get back to this. Localhost 5,500, I believe. Yep. Plex P5. No, sorry. Where were we? This is it started with a K. There we go. Okay. Right. So I'll leave it at that. So hopefully you like the sketch. Add colors to it. Maybe change the shape a little bit. Maybe change the angle of the triangle. Right. It doesn't matter. Try something different. And if you make mistakes, that's fine. Try to figure it out. resolve the issue. Yeah, that's it. Leave a like if you like the video. Let me know down in the comments below what you thought of this, and see you in the next video. Thank you for watching. See you in the next one.